This tutorial is specifically for the Adafruit GFX library, although you might be able to adapt the same principles to a different library. To begin, I wanted to use this specific font style for a project. I had this bitmap image of the digits, but that's it. There's no matching Arduino font. And I only needed the digits 0 through 9, no other characters, and they needed to be exactly 24 pixels wide by 32 pixels tall. Per the Adafruit specs, there's this command that will directly draw a bitmap from memory. It's very straightforward. You give it a screen location and size and data for the bitmap, and it just draws it on the screen. One caveat though, the image is monotone color. Each pixel is either the selected color or it's transparent. So this is great for sprites and characters, just what I need here. I can't use the image to CPP app that's referenced in the Adafruit GFX graphics library because the original bitmap is much higher resolution and the character edges are softened, so scaling it down this much would have resulted in irregular and chunky characters. So I came up with this technique that uses Excel. I suspect this method will also work in Google Sheets, but you'll have to experiment. I'm assuming from this point on that you already know how to use Excel and can create simple macros. If not, stop and go study those techniques. First, set your spreadsheet row heights and column widths to get square cells. Then mark out a region for your character. Here I'm making a character 24 pixels wide by 32 pixels high. You can do any height you wish, but your widths must be multiples of 8. That's because these bitmaps break each byte down into 8 pixels of width. You can use white space, of course, to fill in non-used areas. Next, use conditional formatting to shade a cell black if it contains the number 1. I also set the font color to red just to make it stand out against a black background. Insert the image into the spreadsheet and set its transparency to about 50%. Then crop off any unnecessary portions and scale it up or down so that the portion you want to copy uniformly fills the region you created earlier. Then manually type in 1s to copy the image. It won't be a perfect copy. Remember, you are working with only a few dozen pixels, so don't fuss over it. When that's done, we need to convert the 1s and 0s to hexadecimal values to copy into our Arduino code. What I did here is brute force, but it works. Begin by converting the first 8 pixels from binary to decimal. The most significant bit is on the left, so multiply it by 128, then add it to the next bit multiplied by 64, and so on for all 8 bits. Because my character is 24 pixels wide, I'll need 3 cells to hold this data. Now you can see why a character must be multiples of 8 pixels wide. Copy and paste the formula accordingly for the entire image. Next, we are going to convert the decimal numbers to hex. That's easily done using the built-in Excel formula. Make sure to use the second argument in the formula to force it to show 2 digits. The last step requires using a macro, but it's not that complicated. I'm going to post the code on the screen and also put it in the comments. You can assign it to a button like I did here. What it does is read through the hex values and format them into array notation. When the macro finishes, it copies its output directly to the clipboard, so you can then paste it into your code. Note that the macro starts reading from the cell in row 30 and column 32, so build your spreadsheet that way, or else alter the appropriate values in the macro. The final step is just to paste the clipboard contents into your code. You'll have to specify the variable name, of course. This macro just provides the data. Repeat these steps as needed for additional characters. Here's what my finished characters look like. I'm using them for a frequency display on a custom radio project. That's it. Thanks for watching, and be sure to check out the other videos on my channel.